This is Unit 8, Section 8.2. Today we're going to be looking at two types of errors that we could make based on our data collection. And because we're not 100% confident, then these are a couple errors that could happen. And so we are on our second day of 8.2, a little blurry here, but we are going to identify type 1 and type 2 errors, as well as calculate probabilities and factors that go into affecting the probability of these errors. So when we draw conclusions from a significance test, we hope that our conclusion will be correct, but sometimes we are going to be wrong. There are two types of mistakes we can make, a type 1 error or a type 2 error. And this idea comes from the fact that if we were thinking about what we did in our last unit, where we said, okay, there's an unknown true parameter here, some proportion. Our p-hat could capture that when we build an interval. But we might have an interval that still misses it, even though we've done the data collection the same for this sample as we did for this sample. That's why we never have a confidence level that's 100%. I mean, that would be just a huge, ridiculous interval. And so since we don't have that, it's possible, even when we're really confident most of our samples are going to capture the true parameter, there's still the possibility that we might get this one that still doesn't hit the true population. This would be an error. This is a mistake in our, it's not in our data collection, it just happens that we missed the true value. And so in this case, if we reject the hypothesis, so the claimed idea, but we in fact find out that the claim is true, okay, what this is called a type 1 error. And we use Roman numerals there. And so this is, you found evidence you shouldn't have found. So this is saying we reject the claim, but the claim was true. That's an error. If we reject the claim and the alternative is true, or the claim is false, this was a correct conclusion. We didn't make an error in this case. Because if the alternative is true, we should be rejecting the claim. The other part that we could do is fail to reject the claim. Okay, based on our p-value, based on our conclusion here for our hypothesis test, we can reject or fail to reject. Remember, we never accept the alternate or the null hypothesis here. So when we fail to reject, it's possible that the claim is true. Okay, well, that's a correct conclusion. We didn't make a mistake there. However, if we fail to reject the claim, but the alternative is true, this is our type 2 error. And this means we failed to find evidence that we should have found. And so I kind of think of these as there's two kind of crime scenes that I'm thinking of, crime cases that I'm thinking of. I think of O.J. Simpson and the one that was up in Minnesota, and his name is escaping me. I think it was Stephen Avery. And so Stephen Avery was somebody that they claim, they found all this evidence, but then he claimed his innocence forever. And so that's where we found evidence that we shouldn't have. And the theory in that, and I think it was the Netflix show that was called Making a Murderer, and it was where they maybe planted evidence, or maybe something went wrong, or maybe he was just literally in a the wrong spot at the wrong time there. They found evidence you shouldn't have. Type 1 error is a Stephen Avery. I think of O.J. Simpson with the type 2 evidence. We failed to find the evidence that we should have. And so when we think about these types of errors, we want to think about our sample. We have our sample. We've done good data collection. It was random. It was independent. It met the large counts conditions. That's not our mistake. Our mistake is that our particular sample that has variation among all of the other possible samples happened to reject or fail to reject incorrectly. So for example, the two errors that we could make if we were in a jury trial would to be send an innocent person to jail, okay, so that would be like Stephen Avery, that's our type 1. And the other error that we could make is a guilty person goes free. Okay, that would be our type 2 error. So I think Stephen Avery, type 1. I think O.J. Simpson, type 2. If there's a more updated one that makes you remember those, that is okay as well. And so when we think of these, which one is worse? Where do I want to kind of hedge my bets on? Do I want to send an innocent person to jail? Is that where I'm willing to risk my mistake, my error, or am I willing to send a guilty person free? This is a huge ethics dilemma when it comes to deciding that, and it really is your decision as the researcher, as the person running the experiment. This would be something that you would want to consider as you're doing this design and setting a certain significance level that would either reject or fail to reject more often. So when we think of our type 1 error, okay, this is when we reject the claim when the claim was actually true. The verdict was guilty, but they were actually innocent. The probability of this happening is equal to our chosen alpha. Okay, so a type 1 error equals our significance level. And so that's going to be something that we want to consider when we're choosing it, which is why we, for medical studies, have like 99.9% as our confidence level, and we'd only have a rejection region of 0.1% for our alpha. Those are things that we want to consider and say, when we have this claim, we're only going to reject it when we have so much evidence against it that it probably is going to be that true. We're only going to leave a very little wiggle room for that. And so if we happen to make that error, that's when we accept, when we reject the claim and the claim was actually true. The probability of that is equal to alpha. So this is something that we have to consider when we're choosing alpha. A type 2 error is when we fail to reject the claim when the claim was actually false. So the verdict was innocent, but they were actually guilty. We let an innocent person go free. A guilty person go free. The probability of that happening is often called beta, which is a long, ugly process to calculate. Okay, that is something beyond the scope of our class, but generally speaking, increasing your sample size and or your significance level will decrease the beta. So when we increase sample, okay, increase alpha, this is going to act against our new criteria here, beta. And so when we think about beta, this is what's called power here. It's related to beta. The power of a test against the alternative is the probability of correctly rejecting the claim when the claim is in fact false. So the verdict is guilty when they really are guilty. Power is 1 minus beta. Okay, so it's the opposite of beta. And so when we think of kind of the relationship to this, our type 2 error is going to be 1 minus this beta. You will not have to calculate beta, but if given beta, we need to be able to find the power because this is the probability of our type 2 error. And so when we look at our first example, it says, should Rockford switch to bottled water? A shoe company disposed of some harmful chemicals into the groundwater in Rockford, Michigan. The limit of this pollutant in drinking water that is considered safe to consume is 70 parts per trillion. A random sample of 200 households found 70.5 parts per trillion average in the tap water. Should Rockford switch to water bottles until the groundwater is cleaned up? All right, so practicing stating our null and our alternative. Okay, the null here, this is going to be our average should be 70 parts per trillion. So we're going to say it's 70 parts per trillion. Okay, that's what the claim is that it should be. However, they're worried that they should be switching to bottled water, meaning that the alternative to that is that it is greater than 70 parts per trillion here. And so when we look at this, this is the idea of we're interested in the average amount of this harmful chemical that's in the groundwater. If we said not equal to, it would mean we don't mind if it's lower or higher. In this case, we just are looking that it's too higher here, switching to bottled water until it's cleaned up. So improving that. So we want to make sure we're using the context to come up with this one-sided alternative. So if we wanted to explain what the type 1 and type 2 errors would be, this is where we would say a type 1 error is finding evidence that the average is greater than 70 parts per trillion when it isn't. Okay? That's what the type 1 error would be. It's finding evidence that we shouldn't have. We found evidence of our alternative, but we shouldn't. And so what happens there is that we would end up switching to water bottles or bottled water when groundwater is fine. That would be kind of the error that we would be encouraging there. We would say, okay, we have found evidence that the average groundwater pollutants is greater than 70 parts per trillion, so we're going to tell the households in Rockford to switch to bottled water. You need to go ahead and switch to that. And so when we look at this, that would be a mistake. If we're now going to spend lots of money switching to bottled water and investing in that and cleaning and doing a boil order, but the groundwater is fine. The type 2 error in this case would be failing to find evidence that the average is greater than 70 parts per trillion when it actually is. That's a mistake. We have our sample and it's not showing us the evidence that it's greater than 70. This means we're going to continue using bad water. That's not good here either. This is now going to put the public in Rockford, Michigan at risk of consuming and continuing to drink bad water. This could lead to health concerns. This could lead to maybe poisonings and death. And I know, like, when you talk, if you've had a debate class, it's almost like those catastrophic things. Like, which one's worse in this case? I would definitely say the type 2 error. Type 1 error is almost erring on caution. Like, we found evidence that it is, okay, so we're going to keep testing it again, but for the meantime, let's switch to bottled water. If we fail to find the evidence that it's greater than 70 parts per trillion when it actually is, we're going to now put into jeopardy the health of all those residents in that town. Type 2 error in this case is going to have a stronger consequence than a type 1. So I would want to control the probability of my type 2 error by controlling the power there. Okay, so that's kind of what part C is looking at here. Which error would be worse to make? And that is where I would say type 2. And the reason we would choose that is because people could get sick, die, all of that. I think as soon as you have a consequence where somebody's health is in jeopardy, even if it's a monetary risk for a type 1 error, this one's going to be worse overall ethically. So which significance level might be appropriate to choose in this case? Okay, so that's where we want to try to think, okay, if this is about alpha, that's my significance level. This is 1 minus beta. That's how I find the error of my type 2. Okay, I want to think about controlling this. This is not that bad of a mistake. I'm willing to make a type 1 error in order to save myself from making a type 2 error. And so as I look at my options that they provided here, I'm going to choose the biggest one. I would rather us increase our probability of making a type 1 error, and I would rather that then will decrease the probability of making a type 2 error. So I would choose the 10% one because the outcome of the type 1 error isn't as bad. In fact, I mean, it's our erring on the side of caution there. And so it says on E, if the probability of making a type 2 error, in this case was 0.12, okay, what is the power of your test? What does that mean? How could you then make your test more powerful? All right, so if they're telling us the probability of a type 2 error is equal to 0.12, okay, so they're telling us this is the beta here. So if we wanted to find power, power is going to be 1 minus that beta. So we'll do 1 minus 0.12, which then gets us this 0.88. All right, so what does this mean and how could you make your test more powerful? Okay, this means that there is an 88% chance of correctly rejecting the claim when it is true. Okay, how can we make our test more powerful? Increase sample size, always a good thing, and increase alpha level, so our significance level. So this is where by increasing this to type 10, we've reduced our probability of making a type 2 error. Those two things are inversely related. As I increase type 1, I decrease the type 2, and vice versa. So if I switch it up and decrease my type 1, I'm increasing the type 2. So we want to consider the outcomes here as we're looking at the possible errors that we could make. All right, in the last example here, it says slow response times by paramedics, firefighters, and policemen can have serious consequences for accident victims. In the case of life-threatening injuries, victims generally need medical attention within 8 minutes of the accident. Several cities have begun to monitor emergency response times. In one such city, the mean response time to all accidents involving life-threatening injuries last year was 6.7 minutes. That's looking pretty good. It's less than the average or less than the 8 minutes that they need the medical attention. Emergency personnel arrived within 8 minutes of 78% of all the calls involving life-threatening injuries last year. The city manager shares this information and encourages these first responders to do better. So at the end of the year, the manager selects an SRS of 400 calls involving life-threatening injuries and examines the response times. State the hypothesis for a significance test to determine whether the average response time has decreased. Be sure to define your parameter of interest. All right, so our parameter we're interested in studying here is the average response times to all accidents involving life-threatening injuries. And so in this case, the claim that's been made is that we need to be there by 8 minutes. Okay, what we want to do, as the city manager is suggesting, is that we want to bring down that average. And so far, they have been able to do that. So right now we have evidence that would support that they are decreasing it from the 8 minutes they're getting there in time. The city manager wants to make sure that they're staying consistent there. So on part B, it says describe a type 1 and a type 2 error in this setting and explain the consequences here. So a type 1 error in this case would be finding evidence of the alternative. So finding evidence that the average is less than 8 minutes when it isn't. Okay? The consequence of that is going to be, okay, we've found evidence that it's less than 8 minutes, and so we're not going to change anything. We think we're doing a good job. So we're going to not seek out ways to improve. More people die from their life-threatening injuries. I mean, there's other consequences here. If we think we're doing a good job, we're not going to seek out that improvement. Okay, a type 2 error is when we're going to fail to find the evidence that we should have. So type 2, failing to find, good grief, evidence that the average is less than 8 minutes when it is. Okay, so now I have failed to find the evidence of my alternative, so now I have failed to reject the claim. So what happens now? Now the city is going to spend money trying to improve their times. This is going to hurt morale of the employees and first responders. I was trying to think of something where, if you're accused of, it's like when your parents come in and say like, oh my gosh, you haven't unloaded the dishwasher. And you're like, oh my gosh, but I had a big project due and I've done it every single day. Today is just, you happen to have this one sample where I haven't done it. Don't look at it right now. I've done it for the last month without any, requests or anything like that. That's what's kind of feeling like it is happening here, where in this case, we're not, they're going to spend more money trying to improve their times, but they shouldn't have to. The morale is going to be hurt because they're going to say, you need to be faster. And that puts a lot of pressure on the first responders to do better, even though they're probably doing well and doing okay. So in this case, for this example, I would say our type 1 error is going to be worse here. Finding evidence that the average is less when it actually isn't is going to hurt people. They're not going to try to improve their times. They're going to have people that succumb to their life-threatening injuries more often. So that's the last part on part C, which is more serious. I would say, obviously, in this case where we have the consequence of people dying or succumbing to life-threatening injuries and things like that, that's going to be the more serious one. All right, type 1 error, finding evidence of the alternative you shouldn't have. Type 2, failing to find evidence of the alternative that you should have. So let me know if you have questions on these, as we will continue to explore them as we continue in this unit. Thank you. Have a good day.